College Algebra Exam 1 Review 1.1 through 2.8. Section 1.1, find the x-intercept and the y-intercept. Alright, so this axis right here is the x-axis, and this axis right here is the y-axis. So the x-intercept is where it intercepts with the x-axis, which is right there. That's 1, 2, 3, 4 to the right, and it's not up, it's not down. So we would say this point right there is 4, because x's go first in an ordered pair. Ordered pairs are always in the form of x, y. 4, and then because it doesn't go up and it doesn't go down, we call it a 0, right? Because, you know, the origin, for instance, is a 0, 0, right? Okay. So that right there, because again, it goes through the x, this is right here, is our x-intercept, right? Okay, now what about the y-intercept? Well, same thing's true over here at this point right there, except in reverse. So now at 0, it doesn't, the x value, it doesn't go left, it doesn't go right, it just goes up. So the x value is a 0. But now because it went up 2, the y value is now a 2, right? The y value is a 2. And over for the x-intercept, the x value is a 4. The other one is a 0. And that's not an accident. So all y-intercepts are going to have a 0x value, and all x-intercepts are going to have a 0 for the y value. So the opposite's going to be the 0 for x and y intercepts, and that's a nice thing to remember. So we got our x and our y intercepts over there. Now it says, what if f of 4? What is f of 4? Now what that's really saying is, now the general way to write that would be like f of x, right? But instead they're saying f of 4. So what they're really saying is, all right, so f of 4 is really saying, well, if x is 4. And what they're really saying there is y. So right, what they're saying is, what's the function's value if x is equal to 4? Or what is the y value when x is equal to 4? Or I can even put it right as an ordered pair, right? So if x is equal to 4, what is y? Okay? So what is x? Well, if x is equal to 4, y is 0. Okay. Now they also ask about the domain. The domain are all the x values, and they ask about the range. The range are all the y values. So it's saying, what is the domain? Well, that's all the x values, right? Well, this little arrow over here goes off to the left forever, and this little arrow to the right goes off forever as well. There's positive infinity off to the right, there's negative infinity off to the left, and there are no holes in this function. So in this case, we would say the domain is negative infinity to infinity. Okay, what about the range? Well, this does angle slightly up towards the, you know, on the left side, it does angle up towards the upper left, and on the bottom right, it does angle down slightly, and it continues to angle down forever. Okay, and again, up here is the positive infinity for the y values, and down here are the negative infinity for the y values, right? So the y values are negative infinity there, the y values over here are positive infinity. Okay, so what we would say is the range is going to be negative infinity, which we had over here, all the way to positive infinity, which we had over there. So that's the range. All right, so section 1.2, solve for x, beware of restrictions. Okay, so first thing is we would get rid of any decimals or fractions. There are no decimals or fractions, so we move on to the next step, which is, in this case, distribution. So we say 2 times x, which is 2x. We say 2 times negative 3, which is negative 6. We keep the positive 2. There are no parentheses on the right side, so we just keep the 3x minus 7. Next step, we combine like terms. We only have a 2x, so we just bring down the 2x. But we do have a negative 6 or subtraction of 6 and a positive 2 or addition of 2. And negative 6 plus 2 is negative 4. And then we rewrite what is on the right side because there are no parentheses. Next step is we're going to get all the variables on one side. It does not matter which. If you don't want to deal with negatives, we could, for instance, subtract 2x from both sides and get all our x's on the right side. That's fine. But there's nothing wrong if you want to do it the other way as well. So the 2x's cancel out. It leaves you a negative 4 on the left, and 3x minus 2x is just 1x, or just x, with an implied or understood 1 coefficient, minus 7. We want to get the x by itself, so we have to undo the subtraction of 7 by adding 7. And whatever we do to one side, we do to the other. These cancel out. And that leaves me negative 4 plus 7, which gives me a 3 is equal to an x. Now, if 3 is equal to x, then x must be equal to 3. It works both ways. So we have an answer. If we were sufficiently motivated and you have enough time on the test, you may want to go back and you might want to plug that answer back into the original equation and see if it in fact makes it true. If it does make it true, then you probably have the correct answer. If it does not make it true, you probably don't have the correct answer, right? So we say 3 minus 3 is a 0 plus 2. 2 times 0 is a 0 plus 2. 0 plus 2 is just a 2. Okay, on the right side, it says that 3 times 3, I wrote a 2 instead of a 7, it's supposed to be a negative 7. So 3 times 3 is a 9, and then 9 minus 7 is a 2. And would we say 2 is equal to 2? Yes, 2 is equal to 2, so we know that the answer must be 2. Now you probably want to write this in a set notation technically, so you just do the set notation, a little squiggle right there, and you put a 2 in it, and that would be the correct format. Sometimes this format is better than just saying x is equal to 3, though x is equal to 3 is probably okay. Okay, now what do we do for the next one? Now notice the first thing I said on the previous problem is if there are any fractions or decimals, your first step is to get rid of the fractions or decimals, right? The same thing's true even if it's a fraction made out of polynomials or a rational expression or equation. The same first step applies. Now in this case, to figure out what the least common denominator is, which is what you're going to multiply through everything to get rid of it, you have to do factoring first. So I have to factor this one out. It's a simple factoring. This is a pattern. You have a perfect square, square root of x squared, minus a perfect square, square root of 25 is 5. And what that allows you to do is x plus, right? The square root of x squared is x, put it in the first place of both, opposite signs, and then you say the square root of 25 is a 5. So that's the factoring of that. Now, we want to find the least common denominator, and in this case, we have to include each one of these denominators, each one of these factors, to the highest power. And I put parentheses just to really emphasize that, right? That whole thing is a factor as far as we're concerned, right? So that's a denominator. So we have one of each of those, one in the first one, one in the second one, and then even though there's another set in the last one, each of them still only occurs once, right? Each of these only occurs once at a time, so we are going to include them only once. Okay, so now what we have to do is we're going to multiply this entire equation by this whole least common denominator here, the x plus 5. We're going to include the whole thing. Now I'm going to write this extra step. You don't have to write this extra step, but I'm going to write this extra step to emphasize what's actually happening. So if I distribute this through the entire thing, I might even run out of room on this one, you end up with this situation right here, right? And then we distribute it. So we distributed the first one, we distributed the second one over here, which now we have a 2 times x plus 5, x minus 5, over x minus 5. And then we distribute it to the last one, which is 32 times x plus 5, x minus 5. And then we put that over the entire thing of x plus 5 in the factored form, x minus 5. Okay. Now the reason I'm saying is you don't really have to write the step out is you can mentally cancel out. Like on the first one, the x plus 5 will cancel out, leaving you the x minus 5. And that is in fact what we see here, right there, right? And then we're just left with 4 times x minus 5. So normally you probably just do that step mentally. You don't actually write it out. For instance, the second one, if the denominator on the second one, the denominator underneath the 2 is x minus 5, well, the x minus 5 is going to cancel out, leaving you the x plus 5, right? Because we're distributing this entire denominator to every one of the terms on both sides of the equation. So what happens is the x minus 5 cancels out, which is what we would have predicted, leaving you plus 2 times x plus 5. And then finally, we distribute it to the other side of the equation, the other term on the other side of the equation, and sure enough, both of them cancel out, which is what we would have predicted. So we could have just kind of done that step mentally. So usually you're probably not going to see this step right here. You're probably going to skip that step and do it mentally eventually, and then you'll just skip straight down here to the one without the cancellation. You just do the cancellation mentally and then move on. Okay, now at this point we're going to do distribution. We got rid of the fraction, so we do distribution. So 4 times x is 4x. 4 times negative 5 is negative 20. Okay, now we're saying 2 times x. Well, that gives me 2x. 2 times 5, we say that gives me a 10, and that leaves me a 32. What do we combine? 4x plus 2x gives me 6x. Negative 20 plus 10 gives me negative 10, right? The negative 20 plus the positive 10, and then we say equals 32. Then we try to get the 6x by itself, so we undo the subtraction of 10 by adding 10. Whatever we do to one side, we do to the other. That leaves me 6x is equal to 42. We undo the multiplication of x by 6 by dividing by 6. Whatever you do to one side, you do to the other. And that leaves you x is equal to 7. Okay, so now we have x is equal to 7. That seems like a perfectly fine answer. Now, we do want to make sure that if you plug this number, the 7, into one of the original equation, it doesn't give you a 0 in the denominator, right? So, for instance, on the first one right here, right? If that x had been a negative 5 plus 5 would be 0. So if we would have gotten the answer of x is equal to negative 5, that would not be a valid answer. If you look at the second denominator, it's x minus 5. If you would have gotten the answer as x is equal to 5, that would not have been valid, right? That variable or that value of the x's is not in the domain or possible values because it would make it undefined. It would give you a 0 in the denominator, right? So this actually has some limitations on the domain. And because it has limitations on the domain, if we were to get either a negative 5 or a positive 5, that would not be considered a valid answer. But 7, that's probably a valid answer. If you have the time, you can go back and plug that in and check to make sure that that's a valid answer.